So the next couple slides, we're going to talk about some of the trends in retail and CPG. There's no question that there's money being spent, given the trillions of dollars that consumers have in their pocket. The real question is, given what's the trends that are going on, is how do you influence or inform people on where to shop, how to shop and buy, and that's changed. All of those behaviors from a consumer perspective have changed. And there's an interesting stat from McKinsey. They had a report that just came out that said of the top 15 CPG players, only 5 are also among the top sellers on Amazon. And so the way that people are buying product and the way that their behavior is being influenced has changed radically. It's all different. And so, one of the interesting areas, you'll see the circle, it says $30 billion in AR and VR investment in retail by 2020. So AR is augmented reality and VR is virtual reality. That $30 billion is essentially zero today. And so they're stating that over the next 3 to 4 years, there's going to be a huge amount of investment in that area to change and influence the way that consumers buy, and also the way that you build relationships with those consumers. And so on the next slide, if you take a look at the supply chain and what's happening with that today, basically Accenture has labeled this the digital supply network, and this is the thinking that with the external disruptive influencers around social media, mobile, analytics, and cloud, that the traditional supply chain models are essentially obsolete. And the big mantra that you'll hear from everyone today is that the currency of the future is now speed. So what we believe is that the more you can make data fast, actionable, and intelligent, both from data at rest and data in motion, the more likelihood you'll be able to build a long-term relationship with a customer. And so again, we think that this is really transforming the way that you get insight, and that data insight from data is really the key, and that's the foundation.
And so the classic, and I think at this point pretty well-known challenges to implementing fast data systems today, fast and scalable data systems today, is just the existing data infrastructure. So the legacy systems that are the current workhorses are just not designed to handle the volume and variety of data. The concurrency requirements now, when you have systems that were designed with a certain concurrency expectation, and you may now, as you open up the range of analytic possibilities, these systems are just not designed to handle thousands of simultaneous requests, and certainly not with a sub-second response time. How you can keep a good SLA as concurrency goes way up is just pushing a rock up a hill on traditional systems. And again, comes down to the hardware that underlies it, how many threads it has available, how many requests it can actually handle. Certainly then as well-known data integration challenges. So when you have multiple data silos, so for example, very commonly one keeps inventory system data separate from social media feeds, for example. You build a modern news system, or there's a cloud component where your social media data is, and you've got legacy systems on-prem, and how you manage these multiple data silos from a data integration perspective is the well-known sort of spaghetti of just complexity of connections, brittle data integrations, and processes. And really then it's a question of legacy architecture. that the architecture designed, a decade ago in many cases, is just it's not aligned with the requirements of doing fast analytics on very large amounts of data. So this is, from the dawn of time, always the case. You have existing systems. So the question of how you can efficiently move to take advantage of GPU-powered database analytics is where we have some thoughts. So the main solution of bringing GPU compute into this context, how to bring that capability, the power of that to be brought to bear into these CPG use cases is really, it's a two-part. I'll speak to the first one, which is really how to bring accelerated analytics. So this is using Kinetica's database, which again is, and we'll cover the architecture in the later half of the program, but we'll just confirm now. This is an in-memory distributed GPU-powered database. So if you put this very compute-dense, so small footprint database into this environment with the challenges from the previous slide, you can immediately shorten the data processing time. You can visualize much more data. You can uncover patterns in sub-second times. So the use cases then for this quality of accelerated analytics then has been quickly adopted in ad tech, where anywhere where geospatial either identity, branding, or analytics are needed. So looking at where certain trends are happening, where anything with latitude and longitude data, customer preferences. Also, then use cases include pricing optimization, real-time supply chain, as described earlier, for doing replenishment and looking at out-of-stock situations, how to do inventory management. Assortment optimization and planograms, so what mix of products should be delivered and for sale when and where. Any type of logistics. So again, there's many places where having this quality of accelerated analytics can be brought to bear.
And so deep learning is the other solution area, right? And the interesting thing is that accelerated analytics and deep learning are really aligned together, right? So for deep learning, you basically use the insight and the patterns that come from the accelerated analytics to basically build models and feed data into your deep learning frameworks. And for for retail and CPG, there's a number of different areas that deep learning is being investigated and used in. And the big one is around theft and shrinkage. It's a huge problem today. And a number of customers think that by using deep learning with object matching, that they'll be able to reduce that by up to 90%. It's also, used in a number of different areas, right? Predictive sentiment analysis, right? How do customers, how do they think customers are going to buy or want to buy, and when, where, of what type of product. So it's a natural tie-in to accelerate analytics, and we think there's going to be a lot more use of deep learning as the time goes on. All right.